Right. I think we were discussing just let's wait for about 2 or 3 minutes until the others come. Only one has come. Let's see, because others are also coming. Yeah, another one student came. Right, we will start. Otherwise, it will be just time wasting for the others who came on time. Recording the yes, okay. I think in the previous week, what we discussed was about the shallow foundations, and this was the book that I was referring, and we discussed this the ultimate bearing capacity of the soil, and this would be the equation for the strip foundation, and then for the square foundation this would be the equation, and the circular foundation this would be the equation, and this is how you can find the NC, NQ and gamma values, and using the table or using these equations we can determine this NC, NQ and gamma values, and this is Meyerhoff's method. Meyerhoff's equation, it has a large number of parameters to be found, and for the Meyerhoff's equation these are the NC, NQ and gamma values that should be used there, and these are those shape factors depth factors and inclination factors, the equations for them. And when the water table is available, I could not share that PDF with you, Neil. That reference book. Let me share that PDF also with you. I think how can I share that one? Classwork, create material, reference book, Brajayam Das. We can upload references. That's the book. I think this should be the book. Yes, this is the book, so that you can see those figures, right? Let me upload that now, otherwise I will forget to upload them, right? Yes, it is uploaded now. Right. Therefore, you can see, you can determine this ultimate bearing capacity when the water table varies. So some terms will be changed. Then the factor of safety we discussed, and I think we discussed this example. And did we discuss this example? අපි මේ example එක discuss කළාද? Did we discuss it or not? Oh, silent. Right. Shall we quickly do this one? I will give you just 5 minutes. You can ask any question, right? I think what you have to do is just applying those parameters just to revise what we have done in the previous week. Today we will be discussing another thing. Okay, shall we revise what we have done first? Right, shall we see the answer? The water table is here, therefore case 2. However, we discussed this one in the previous week using Tersagi's method. This is regarding the Mayhoff's method. So, since this cohesion becomes 0, one part will be 0, and then you will get only these two parts. And you can find the factors, so shape factors, inclination factors, and etc. Then you will get the ultimate bearing capacity as 12 point something. And what you have to find is the load. Therefore, you can use the factor of safety as 3. It is given factor of safety 3. So that the answer is 336 using Mayhoff's method. Right? Any questions? If you have any questions, please let me know. Right, no questions? So let's move to the today's content that I hope to do. Right. Let's assume that now this would be the ground surface, right? Now you are going to construct a house here. Therefore, this would be your ground surface. Now zoom is not there, therefore it is somewhat difficult to so this is the symbol of round surface, right? Now you are going to construct a house or a building here on top of this, right? Now you are going to construct this kind of a thing. Now before construction of this, we will have to design the foundations, right? නෑ මේ පැත්තට රස්නික දැල්ද house of plan නෑ if we take the plan view of this, then the plan view would be, let's take a simple one. This will be the plan view with 4 columns, 1 2 3, just a simple building, right? 4 columns. Then if we assume that this the dimensions are, if we assume the dimensions, shall we take it as 10 meters? If we assume it as 10 meter by 10 meter, now this side would be 10 meters, and this side will be again 10 meters, right? Then shall we assume the live load and dead load? Then normally let's assume that the live load is just values, right? 5 kilonewtons per meter square. And then we will take the dead load as 20 kilonewtons per meter square. Therefore, the design dead load, sorry, the total design load would be 1.4 times live load plus 1.6 times dead load. That would be 1.4 times live load is 5 plus 20 times 1.6. How much? That is 39 kilonewtons per meter square. Let's take it as 40. Let's take it as 40. Then total load from the structure. Now this is just some value, right? This is how actually this should be taken from a proper structural analysis. Now just for some values I got this one, right? Total load from the structure would be 40 times area is 10 by 10. That would be 4 ting 4000 kilonewtons. Therefore, load per one column would be 1000 kilonewtons, right? Therefore, load per one column would be 1000 kilonewtons. Therefore, if I draw one column here, what happens is there will be a column like this, and there will be another column like this, and there will be a load applied on this one. There will be a load applied on this column by this column on the ground about now these are just values, right? That is about 1000 kilonewtons, and this one also 1000 kilonewtons. And what happens is this comes up to the column base. This comes up to the column base, and the column base will transfer that load to the ground. This column base will transfer that load to the ground. Right? That is what happens. Now we should design this B value. Now what we are going to find is what will be this B value, and we will take that this value is how much? Shall we take it as 1.5 meters? Right? This is our question now. Let's assume that assumption water table is at very below level. Right? If you have anything to write down, you can write down. But this should be taken from a proper structural analysis, right? I just took it for because I need to explain the method. That is why I just took it, right? If you have anything to write down, please write down. Now these are just calculations and not the real values, right? I did it because we need just a number. Normally the structural engineers will give this. So you can draw this one also. Our final target is to determine this B. Right now you can start. In this one, shall we assume that factor of safety equals 3. Therefore, the factor of safety equals factor of safety equals ultimate bearing capacity, that is Q ultimate divided by the allowable stress. On the foundation. Therefore, the ultimate bearing capacity Q ultimate has to be found from the equation from the Mayhoff, you can use Mayhoff equation or Tersagi's equation. You can use whatever equation there. Therefore, for the numerator, you can use Tersagi's equation or Mayhoff's equation. And to determine the allowable stress in the denominator, you can take the stress is 1000 divided by b squared, because we will assume that the footing is square shape. Now what we have to do is we will have to find this one. This one means the ultimate bearing capacity of for this one. We will find it and put it here. Right, quickly do it. This will be in terms of B, right? This will be in terms of B, because we don't know the B value. In the earlier example, we know what the B value is. We know this value, but here we don't know that. Quickly do it. I will give you 5 or 10 minutes. We will use the Terzaghi's equation, right? I think someone joined. Yes, any answers? Yeah. Yeah, I think you might have joined this using your Gmail account. I think that is why I had to click admit. Next time, try to log in with your link and email. Right. For this one, you can use this equation. So QU equals 1.3 multiplied by C dash. We need the cohesion value. Those values should be given, right? Let's take cohesion value as 10. Nobody asked them money. Again, that means you have not started. NC, NQ, N gamma should be found for the phi value. Let's take that cohesion equals 10 kilopascals, and then phi friction angle equals 30 degrees. And here you will have to insert the NC value plus, and then we need the gamma value. Gamma equals, let's take 20 kilonewton per meter cube. Then Q means the effective stress at the bottom of the foundation, that is 1.5 times 20, and it should be multiplied by the NQ plus 0.4 times 20 times B. B is the width of the foundation. That is what we want to find. That is B times N gamma. So please find these NC, NQ, N gamma values and put it here. Then you will be able to find this QU in terms of B, right? You will find it in terms of B. Quickly. Please quickly. Yes, I need these values. That means this will be some number plus again some number times b. I need this one and this one. Quickly. If you have any questions, please ask. Sorry.
1,156.88.
Plus
153.04.
මේකද ආවේ මේකද කියන්නේ Could you please check whether others also get this value? At least one more?
Yes. Yes, sir.
Yes. Okay, thank you very much. Does anyone have any questions? How to get this one? මේ ගන්න කවුරුත් බැරි අය ඉන්නවද තේරෙන්නේ නැති අය එහෙම? No, then we will put it there. Insert equation. Now we were here. Yes, we can put it just there, no? Then we don't need this one. We will just put it there. Right. Then what we got is factor of safety equals this one. We need to find or else factor of safety is 3. 3 equals this one. Then we need to find b. We need to find b. So you will get a cubic equation of b. what you can do is you can bring this term there, then it will be 3000 divided by 3000 divided by b squared and that will be equal to this term. Then I will multiply by this b squared, then 3000 is equal to 1156.8 times b plus 153.04 times b cube. මෙන්න මෙතන b squared එකක් එන්න ඕනේ. b squared. Then I will rearrange these terms. First I will write this one. Then plus this minus 3000 equals 0. Then you will find three values for b. To solve this equation, to solve this cubic equation, you need a calculator. In the calculator, you can select. I don't have a scientific calculator now. You can select mode equations and you can select this format and find b. Since I don't have the calculator, I will use online calculator. So the value so I have got 3 values. First one is minus 7.17. The next one is, that should be meters. All the values were selected in SI units, and the other one is minus 1.85, and the next one is 1.47. Yes. So these are the values that I got. We cannot take these minus values for the dimensions of a footing. Therefore, this will be, let's take foundation width as 1.5 meters, or else 5 feet. Therefore, the final one would be something like this. Something like this. The column footing will be something like this with the dimensions this side it will be 1.5 meters. Since it is a square one, this side it will be 1.5 meters. You can just have a slightly higher than this value. Any questions? Now this is for the factor of safety of 3. We can rearrange the factor of safety and see how this varies. So if you have any questions, you can ask. Otherwise, you can note this down. No questions? Right. If you don't have any questions, then we will see what happens when you have a water table here. The same question. We will do the same question. The same question when the water table is here. Water level at the depth of water level is at a depth of 1 meter. Right. Okay. Do the do it again for this one. Factor of safety is 3, and other values are same. Any questions? If you have any questions, please ask. No questions. ළමයි හරි හොඳයි ප්‍රශ්න අහන්නේ. Please give me the answer. Right? I'll give you just 5 minutes. You can follow the same procedure, but this has to be modified. Any questions? Right, if you don't have any questions, we will move to another question. Then we will discuss a model question. So this will be another question. A footing 2 meter by 2 meter is located at the depth of 2 meter in a sand. Sand means the cohesion becomes 0. The shear strength parameters to be used in design being C dash equals 0, phi dash equals 30. Determine the ultimate bearing capacity if the water table is well below the foundation level and if the water table is at the surface. Right. The unit weight of the sand is given. The saturated unit weight of sand above the water table is also given. So shall we change this to 2.5 meters? Right. Quickly do this one. I'll just give you 5 or 10 minutes. Quickly. You will be given a question like this for the exam. Right, I will give you just 5 minutes. 5 more minutes. Let me show you the answer to part B. Is the answer yes, and 2.5, 2.5. You can determine the NC, NQ, and gamma values, and when the water level is well below, you can just use this equation. Check whether you got the NC, NQ, and gamma values correctly, and you can directly use the equation and take the ultimate bearing capacity as this value. Right. Then the water level is at surface. Those values will be adjusted, and you will get the ultimate bearing capacity as 452.2 kilopascal. I'm not going to explain each and every step. If you have any questions, you can ask. No questions means either you have understood nothing or you have understood them very well. So if you have any questions, please ask. Any more question? Any questions? දැන් ස්ක්‍රීන්ෂොට්ස් අරගෙන පස්සේ ප්‍රශ්න අහනවා කියලා ප්‍රශ්න විසඳ ගන්නවා කියලා එහෙම ඉන්න එපා. දැන්ම විසඳ ගන්න. Well, if you don't have any questions, then we will move to the next question of that. Where is it? It's this one. Yeah, a square footing foundation is shown above. Using a factor of safety of 3, determine the size of the footing. Right, you will have to determine the size of the footing. The water table is here. Right, the load is 500 kilonewton, and these dimensions are also given 1.7 and 0.3. The water table is at a depth of 1.7 meters. Yes, all the values are given. Quickly do it. If you have any questions, please ask. Right. So did you find the answer? The answer would be blah blah blah. Every value is given. Then 1 meter by 1 meter square footing. So here you will get a cubic equation to solve. You will get 3 values, and 2 values will be rejected, and you will get only one value, that is 0.93, and that can be taken as 1 meter by 1 meter. You will have to round it off to a higher value. Any questions? Please tell me whether you have done it or not. Otherwise, I cannot follow. Please give a feedback whether you have done it or not, whether it is. Right. If there is no if there are no any questions, then or no clarifications, then there are two assumptions that I can make. Either you have understood everything, or you have understood nothing. So I will assume that you have understood everything. Otherwise, you should have asked any questions. No? So we will have a small break and start at 3 o'clock, starting from the soil compressibility or the settlements. And that PDF is already attached in your classroom, so that you can refer it. And let's have a small break so that you can refresh yourselves and come back. Please come back at 3. Right, now we will start a new session, that is compaction and consolidation under the soil compressibility. I have already attached this in your classroom. The soil compressibility can be viewed in two different contexts. The compressibility, or the ability to compress, that can be divided into two different contexts, that is the compaction and
Sir,
consolidation.
presentation is not shared.
Sorry. Thank you very much. Sorry for not sharing. That means that you are attending. Thank you. Right. Compaction and consolidation. The soil compressibility can be viewed in two different contexts. One is compaction and the other one is consolidation. Right? Both of these contexts tend to compress the soil. Compress means the reduction of the soil volume. The soil volume will be reduced in both of these phenomena. The soil compaction is defined as the method of mechanically increasing the density of the soil by reducing volume of air. And soil consolidation is a process by which soil decreases in volume. According to Carl Terzaghi, consolidation is any process which involves decrease in water content of saturated soil without replacement of water by air. Without replacement of water by air. I mean, here decrease in water content. So consolidation deals with decrease in water content, but soil compaction deals with reducing the volume of air. Right? Therefore, compaction, basically soil compaction is the reducing the soil volume by removing air. And consolidation is the reduction of the soil volume by removing water or decreasing water content. Right? Therefore, as now Carl Terzaghi is the person who has done so many researches on this consolidation. Therefore, he is the father of this consolidation theories. So the next one is the compression due to foundations. That means when the foundations are loaded, soil underneath the foundations will be subjected to additional stresses. That means, as you have seen here, when it is loaded, the soil underneath these foundations will get stressed. I will upload this one also. Right, okay, I will upload them later. Therefore, when the foundations are loaded, the soil underneath the foundations will be subjected to additional stresses. Due to the increased compressive stress on the soil layers, they will undergo volume change and hence compression. Therefore, the soil layers underneath this one will be compressed and they will be settled. They will undergo the settlements. As a result, the foundation will undergo settlements. Therefore, as a result, what will happen is these foundations will be settled. Therefore, all the structure will be settled. Right? That is why we should consider this as a critical thing. The settlement under the structure depends on the applied stress and the compressibility characteristics of soil. The settlement under the structure depends on the applied stress and the compressibility characteristics of the soil. And dissipation of water is slow in clay and fast in sands. Therefore, the settlement will be slow in clays. Therefore, in clays, the settlement will take a longer time, and the settlements in sands will take a smaller time. Let me upload that first. Otherwise, material answers for foundation question. Upload. File save as Lincoln Foundation Engineering Foundation questions. Otherwise, I will forget to upload this one. Right. Therefore, as civil engineers, we need to find the settlement of the compressible layer and the time required for the settlement to complete. As the civil engineers, we are interested in the settlement, how much it will be settled, and the time for that settlement. Right? The amount or the thick or the thickness of the settlement, or the how much it will be settled, and the time. Right? Right. Basically, there are three types of settlements. There are three components of the settlement of the foundations. First one is the immediate settlement, then consolidation settlement, and secondary or creep settlement. Immediate settlement is that immediate settlement happens within a quick time, within a shorter period, and then consolidation settlement and a secondary or creep settlement. If I the total settlement would be the addition of these three settlements. Different components are prominent in different soil types. Right? If you consider sand, in sand, the immediate settlement will be prominent, but in clay, the consolidation settlement would be prominent. However, the total settlement would be the addition of this SI, SC, and SS. This immediate settlement means now if you are walking, when you are walking on a loose soil, what happens is when you just give the force, or when you just walk on the soil, due to your weight, it will be compressed. Or when you just compact it or compress it using a machinery or a machine, then what will happen? The soil volume will be reduced. So these kind of settlements are the immediate settlements that might be due to any external force, and that is due to the compaction. That is due to the compaction. That means that is due to the removal of air. That happens due to the removal of air. So immediate settlement happens due to the removal of air, and with the time this consolidation settlement happens, and then the secondary or creep settlement happens. Now when you keep a force or a stress for a long period on an object, what will happen is, when you keep a force or a stress on an object for a long period, then what will happen is there will be the changes in their molecules or the atoms inside the molecular structure. Therefore, due to the change of that molecule structure, there will be some settlements. That is called as the secondary or creep settlement. That takes a very long time. Very long time means about 50 or something like that. I will show you this one using a graph. Let me draw a graph here. These are the, I will take the x-axis. This way. I will take it as time, and y-axis, this axis, it would be the settlement. The reason that I took this in the downside, downwards, the reason is the settlement is downwards. That is the reason. First, there will be a small or a particular settlement during a small time period. Right? This is yes. This is called as SI. That is the immediate settlement. This is the immediate settlement, and then we have the consolidation settlement. Then we have the creep settlement or the secondary settlement. Right? Then yes, you will get a graph like this, but this should go up. So I will draw it again, starting from this one and this one. Yes, somewhere here. Yeah, the graph would be something like this, right? From here to here, let's take it as dotted lines. So this particular time is very short, and this would be the consolidation. This would be the consolidation, the time for the consolidation. This will be the consolidation period, right? Therefore, let's take this slightly downwards. So this would be the settlement, the consolidation settlement, right? Then after that there would be a small settlement called secondary settlement. That is due to the change of molecular structure. This one. Normally it will take a small time. Let's take it as 1 day, and this will take around 1 year, 1 to 10 years, and this may take about 50 years. So this is what is happening with the time. So you can draw this one. This is the shape of the settlement curve. Yes. Oh, shall we save it? Na? Lincoln Foundation Engineering Consolidation. Right. Please draw it. That is not linear, right? The settlements are not linear. Body lecture මොකෝ සීන එක CDR නේ ඔව් Washington record නැද්ද right ඒක තමයි සීන මේ ලියමු වගේ ටිකයි මම එවන්න මම දැන් මේක ඉවරලා හතරට ඉවරනවා මම හතරට ඉවරනවා හරි sorry now we will learn how to find these 3 settlements separately. Okay, did you draw this one? Now please draw this one as a curve, right? The large settlement is due to the consolidation, and the secondary settlement or the creep settlement is somewhat less. That happens after a longer time because the stresses are being applied for a long time, right? Now first we will see how to determine the immediate settlement, but in this syllabus, in your syllabus, we don't have to determine these immediate settlements. What you have to learn is only the consolidation settlement, right? But I will explain you how to determine these immediate settlements, because just for the completeness, I will explain how to determine the immediate settlements. immediate or elastic settlement. That is mainly due to the distortions of the soil particles that happens instantaneously as the load is applied due to that is with a short period. That means instantaneously with a short period applied due to expulsion of pore water in cohesionless soils and change in shape in cohesive soils without volume change. So this is predominant in sandy and gravel soils. This is predominant in sandy and gravelly soils, but the consolidation is predominant in clay soils. And from the cone penetration test, you can decide the some parameters. That is this FS, IC, UM, QC, QT. Likewise, you can determine these parameters from this cone penetration test, which you will those parameters will be used in the calculations in the settlements in the next equations. So this is the first method, that is Terzaghi and Peck method. Terzaghi and Peck method. Terzaghi and Peck proposed the following relationship to determine the settlement of shallow foundations based on the SPT blow count under the foundation. So using this equation, this rho b is the settlement of the foundation in inches. Now this comes in inches. 3q divided by n. Q means the applied bearing pressure in tons. You can apply the Q value here. N is the average SPT value over a depth of 2b. You can calculate the 2b depth and determine this Q, that is average, that is determine this N, that is the average SPT. And B is the width of the foundation in feet. Now you will have to apply this this B in feet, and N, that is not that has no dimensions, and bearing pressure in tons per square feet. Then only you will get rho in inches. And then next one is Paris method. In the Paris method, this is the equation. If you need to note down anything, I will give you just 1 minute, because these are in inches, right? Inches, feet, and that is not in the metric unit system. Right. Then the next method is Paris method. In 1971, Paris proposed that this equation, where rho is the settlement in millimeters and Q is the pressure from the foundation in meganewtons per meter squared, and B is the width of the footing. A is 200 in SI units. This A should be 200 for the SI units, and CD, CW, CT are factors for excavation, depth of the water table, and the thickness of the compressible layer respectively. And I will explain you how you can find these parameters later. Later means in the next slide. N is the average SPT value over a depth of 2b. N is the average SPT value over a depth of 2b. 2b depth again SPT average value. And this is how you can determine the CD, CW and CT. You can determine CW using this equation, is 1 plus dW over dF plus 3 upon 4 times B, where dW is the depth to the groundwater table, and dF is for foundation depth. If you know these values, then you can apply here and find this CW. And if the water table is above, water table is below, so that you can use this equation, either this one or this one. If the water table is in between 0 and dF, you can use this equation. If it is well below, then you can use this equation to determine CW. And CD, CD and CT are read directly from charts. There are charts for this CD and CT, which is not included here. You can read them from these charts. Right. Then we will move to the consolidation settlement. Right. Let me explain this consolidation with this model. Right. And if you have any questions, please ask me now regarding what we have discussed up to now. Any foolish question? Please ask anything. No. Okay, then we will see what this consolidation is. Now, this is what happens. This example shows what happens during the consolidation. In a soil sample. Now, this container has a spring here and a tap or a void here with a closed lid, whatever it is. And there is a pressure meter there. This spring is considered as the dry soil particles. This is represented as the soil particles, and water is just water. Right? The soil has water, soil, and air. Right. The first one, the container is completely filled with water and the hole is closed. Now here, this hole is closed. Right. This hole is closed, and this is completely filled with water, and this spring is there. That means fully saturated soil. Right. This is fully saturated. There are no any air voids. That means there are no any air voids. That means that is fully saturated. And what happens? What will do is a load is applied onto the cover. Then a load is applied onto the cover while the hole is still unopened. While the hole is still closed, a load is applied onto the cover. At this stage, only the water resists the applied load. At this stage, only the water resists the applied load. Now what happens is the applied load will be taken only by the water. Right? The applied load will be taken only by the water. First, the load will be taken by the water. As soon as the hole is opened, now when you open this hole, when you open this hole, what happens? The water will be released away. Now here you can see, when you apply the load, the load is taken by, or the stress is taken by the water, the pressure. Now here the pressure meter says the same level, but here the pressure meter has gone up. Therefore, it shows a high pressure inside this one. Therefore, the water pressure has increased. But with the time, what happens is, as soon as the hole is open, water starts to drain out through the hole, and the spring shortens. And the spring gets shortened, and the water is getting out, or water is draining out, and what happens to the pressure? Pressure is getting down. And after some time, the drainage of water no longer occurs. After some times, the drainage of water will be stopped, and the water pressure has been come to the same level as in the soil. So now the spring alone resists the applied load. Now the applied load is taken by the spring alone, and that means the full dissipation of excess pore water pressure, and that is the end of consolidation. So this is what happens. Now consider this as a soil element. When the soil element is saturated and there's no any air void inside this one, and when you apply a load, what happens is, when the load is applied initially to the water particles, then the pore water pressure increases, then the water particles will move out. When the water particles move out, what happens is, the pore water pressure gets reduced. When the pore water pressure getting reduced by removing water, what happens? There will be some settlements. Now here, from here to here, there will be settlements. From here to here, it has settled. And when the total load is taken by the soil skeleton or the spring, when the total load is taken by this spring or the soil skeleton, only the dry soil, then the consolidation is over. So this is the procedure, this is a model, this is a model that we can use to describe the consolidation process. Right, we will see by graphs later what happens here. So if you have anything to write down, please write it down. Right. So let me show you a small video. So this shows, wait, I will share it. कोड शेयर करने में So here this shows the water and the spring, and I think what does this show? Yes, this is the gate. Gate means the valve, right? Using this valve, you can take the water out. Here it is draining out. This is closed, and you can measure the pressure of the water pressure using this manometer. The load is increased, therefore the water pressure is increased, right? Water pressure is increased. Why does he give so much of water value? Right, then the drainage is open. Then you can see how the pressure goes down, and the pressure goes down, and it will come up to a certain point where the pressure, all the water is taken out. Then the load can be taken out. Right? That is what happens in the consolidation. And there's another video. Yes, we will see that one also, because we don't have enough time today to do any calculations. So let's see that one. Wait, I will start from the beginning. These three are the basic settlements. Oh, what is this? Sorry for the disturbance. So we will be talking about the applications in the next week. Sorry, the calculations in the next week. So it has used 4 layers, right? So when the load is taken by the springs only, then the consolidation completes. So it is what happens during the consolidation. Yeah, we will also learn the so we will be talking about some more things, so some more calculations actually. Calculation calculations in the next day. I will upload this in the classroom, therefore others would be able to, you also will be able to see them, right? Then what we discussed today is some questions regarding the foundations and the basics of the consolidations. In the next week, we will be talking about the calculations on the calculations on the consolidation. What is the consolidation settlement, and what is the time, etc. Right. For today, we will conclude the session for today, and we will meet in next week. If you have any questions, please raise. Right. If you don't have any questions, we will conclude the session now.